When you view anything at all in the universe, you're not seeing it precisely as it is right now. At the moment you experience seeing it, the speed of light, even though it's the fastest speed that any signal can travel throughout the universe, is still finite. No matter how close or distant an object is, you're only seeing it as it was a particular amount of time ago, at the moment the now arriving light was emitted from the object you're observing. The fact that light has to travel through space, from the emitted object to the observer that sees it, explains why there's a gap that we have to fill in through inference alone. This implies that when a distant observer takes a look at Earth, they're seeing us as we were in the past. Here's what someone looking at our planet would conclude. At present, Voyager 1 is 157.8 astronomical units, or Earth-Sun distances, away from us, corresponding to 14.7 billion miles or 23.5 billion kilometers in more familiar terms. Launched in 1977, it's taken 45 years to get to its present location, which is beyond the determination shock of our solar system. It's one of only 5 spacecraft that's presently escaping from our solar system, and will remain the most distant one for all time unless we launch a new mission to overtake it. And yet, from so far away, farther than any planet, moon, asteroid, or Kuiper Belt object within our solar system, its view of planet Earth is less than a day in the past. It sees us as we were just 21 hours and 46 minutes ago. From anywhere in or even nearby our solar system, the amount someone looks back in the past when they look at us is very small, particularly on a cosmic scale. Another equivalent way to look at this is that even 1 light year is a really long distance compared to the scale of our solar system, a distance that Voyager 1 won't cover for tens of thousands of years. The stars within our own galaxy are the closest objects known outside of our own solar system, with every individual star visible with the naked human eye coming from within the Milky Way. The brightest of them all, Sirius, is located 8.6 light-years away, meaning that, to a Sirian, Earth appears as it did in early February of 2014. Barack Obama is President of the United States. Scotland is about to vote on whether it will remain part of the United Kingdom. Ukraine's pro-Russian president, Viktor Yanukovych, has just resigned from office and fled the country. ISIS poses a burgeoning threat in Iraq and Syria, and the first cases of Ebola are occurring in Liberia, Guinea, and Sierra Leone. And although it's temporary, the atmospheric carbon dioxide level still dips below 400 parts per million during the winter. A sufficiently advanced Syrian could listen to our cultural products, detect our climate and weather patterns, decode our broadcasts, and determine our level of technological advancement. Two-way communication, if they chose to respond to our presence, could be established in a mere 17 years. It just so happens that TOI 700, presently known to host at least 3 and maybe 4 exoplanets, is located 101.6 light-years away from Earth. The innermost planet is rocky. The second planet is likely a smaller, warmer version of Neptune, and the third exoplanet from its parent star, TOI 700e, is about 70% more massive and 19% larger in radius than Earth. If TOI 700e is real, it's also rocky and interior to TOI 700e, changing its status to the 4th exoplanet from its parent star. On this world, Earth appears as it does just after the end of the year 1920. The very first radio broadcasts from our planet are just arriving in the TOI 700 system, beginning with Station 8 Mank from Detroit, Michigan. The CO2 levels in Earth's atmosphere have barely crested the 300 parts per million level, sitting at 303. The beginning of the transformation of our atmosphere from industrial activity would be detectable from this exoplanet. 85% of Earth's surface is still wilderness. Only 15% has been modified, largely for food production. Earth is definitely inhabited, and the first signatures that a technologically advanced species lives upon it are appearing. A round-trip message would take more than 2 centuries. In a single human lifetime, you'd never live to hear a response to a sent message. Once we go beyond the stars in our own galaxy, we're talking about much longer distances and much farther look-back times. The Large Magellanic Cloud has about 10 billion stars in it, and although the full extent of its stars spans about 32,000 light-years across, it's an impressive 160,000 light-years away. From the perspective of this galaxy, the Milky Way would look vast and impressive, taking up 30 to 60 degrees on the sky depending on how faint your skies and how good your eyes can get. An observer looking at Earth would see our planet as it was 160,000 years ago. Homo sapiens had already evolved, but weren't the only members of our genus on the planet, as our direct ancestors were joined by the Neanderthals, the Denisovians, and possibly by the final surviving members of Homo erectus. Our planet would be rich with signs of life, including complex and differentiated life, but the planet was completely in a pre-technological state. Earth was nearly 80,000 years into a long-duration ice age, the penultimate ice age before the rise of human civilization. From an outside perspective in the Large Magellanic Cloud, there's no known way that the presence of intelligence on Earth could have been identified. Now we're really talking about someone looking at our planet as it was a long time ago. Andromeda lies approximately 2.5 million light-years away, the only galaxy in the local group more massive and with more stars than our own Milky Way. Someone present in Andromeda right now would see our planet as it was 2.5 million years ago, long before the emergence of modern humans. In fact, an Andromedan would be able to see the very dawn of the Paleolithic era, where human ancestors first began using Stone Age tools. In addition to fires caused by heat, lightning strikes, and volcanic eruptions, there would be fires at night started by our hominid ancestors, the first members of the genus Homo, but prior to the emergence of Homo habilis. For more than 1 million years, our ancestors live alongside members of the genus Australopithecus on the African continent exclusively, the only places these unique night fires would occur. Giant, long-lasting eruptions occurred during this time on Earth, including Mount Kenya, Little Barrier Island, Norfolk Island, and Boring Lava Field, launching hundreds or even thousands of cubic kilometers of ejecta into the atmosphere, comparable to the Yellowstone caldera or the Great Eruption. Now we're really getting somewhere. Some 55–60 million light-years away lies the center of the Virgo cluster of galaxies. With about 1,000 times the mass of the Milky Way, it's the closest enormous collection of galaxies in the universe relative to our location. The very first black hole ever directly imaged was at the center of the giant elliptical galaxy, Messier 87, which sits at the heart of this galaxy cluster. The light we observe from it comes from 55–60 million years ago, and hence an observer there would see Earth as it was that amount of time ago. The planet is well into a period of recovery from a fantastic mass extinction event, the giant Chicxulub impact that led to the Cretaceous-Paleogene extinction event, which occurred 5 to 10 million years previously. Almost all of the largest plant and animal species on Earth were driven to extinction, including all of the non-avian dinosaurs and all of the flying reptiles. Mammals, small creatures previously, began to rapidly grow, with the Eohippus, ancestor of the horse, first emerging during this time. Small carnivores like Ankylodon and the tree-climbing Creocus dominated the land. Early examples of hoofed mammals, marsupials and placental mammals evolved alongside one another as a separated Pangea began to split the great ancient ocean into two separate waters divided by the Americas. Earth would clearly show itself as a living, inhabited world, albeit one very different in both land masses and atmospheric composition than the one we recognize. Saturn, a signpost in our solar system, would have larger and more massive rings than we see today. Now, we're talking about really large cosmic distances. The first quasar ever seen, a quasi-stellar radio source. We now know that this object is an active, supermassive black hole at the center of a distant galaxy. Although it's located more than 2 billion light-years from us, the light we see from it has only been in transit for 1.99 billion years, as the expansion of the universe has stretched the space between ourselves and this far-flung galaxy while the light completes its journey. Someone observing the Milky Way from such a great distance, if they could somehow manage to make out our planet, would see Earth as it was nearly 2 billion years ago. After recovering from the Great Huronian glaciation, which lasted 300 million years, but ended 2.2 billion years ago, the oxygen levels on Earth began to rise to the few percent level for the first time. Eukaryotes began to emerge on Earth, with cells now containing enclosed, separated organelles to carry out individual functions within a cell. Photosynthetic organisms like cyanobacteria and blue-green algae persist, while carbon dioxide levels dropped to just a few percent. Earth's early atmosphere, rich in methane and ammonia, is gone entirely. Planet Earth is definitely alive, as an atmospheric analysis would reveal, but signs of complex, differentiated, or intelligent life is non-existent. Earth is just another world with successful, but ultimately simple, forms of life. Saturn, meanwhile, would have been ringless like the other giant planets, a condition that would persist for the next 1.8 billion years. I really hope you enjoyed today's video and want to see more content from us. If you do, please subscribe and like. Thank you, and see you later.